All right, so if you've been working with the PHaEDRA collection on the Transcription Center or Zooniverse, then you already know something about these notebooks. So I wanted to start by giving you a little bit of background on astronomy at the Harvard College Observatory. In the early 1800s and the early days of the observatory, astronomers would observe objects in the night sky via telescope and draw images of what they saw. Many of our earlier notebooks contain images such as these, along with written descriptions, which at the time were the only methods astronomers could use to record and share information. But these drawings, while useful in their own way, and especially in regards to early observations of the planets, relied on the astronomers' artistic skills and could not accurately capture the night sky. For example, there's no way to take accurate measurements of how wide the various bands in Saturn's rings are in this drawing from this night as compared to drawings from previous nights. And sometimes it could be a little difficult to ascertain what exactly astronomers thought they were seeing. This was especially true when it came to observing the stars. An astronomer might look at a star and believe it was dimmer or brighter than it had been the night before, but they could only rely on their memory of what they saw. They had no way to take measurements. All of this changed in the 1880s when Harvard astronomers began taking glass plate photographs of the night sky. Using a photograph, along with information about exposure lengths and the emulsion materials, astronomers were able to capture records of the stars, which could then be compared with other records and used to make calculations about what they were seeing. With these photographs, astronomers could finally determine once and for all if a star was really getting brighter or dimmer. Which brings me to the computers. From the late 1800s through the mid-1900s, women were employed by the Harvard College Observatory as computers. These women studied the photographic glass plates at the Harvard College Observatory, comparing different images of the same star to determine how that star changed over time. They kept records of their work and calculations in notebooks. These notebooks, along with the notebooks from the earlier astronomers and observers at the observatory, comprise what we now call the PHaEDRA collection. And PHaEDRA stands for Preserving Harvard's Early Data and Research in Astronomy. The collection consists of over 2,500 notebooks kept in about 135 boxes. They are stored at the Harvard Depository, where they were originally kept as institutional records. In the 1970s, Joseph Timko from Columbia University in New York visited the observatory and worked with Dr. Martha Lillard, the curator of the glass plate collection at the time, to meticulously catalog these records by hand. And he produced a typed catalog of these volumes in 1975. So this is one page from that catalog. It shows a line for each notebook, giving its title, the year the notebook was written, and some additional record metadata. Then in the 1990s, someone converted that typed catalog into an Excel spreadsheet while also re-examining the collection in order to capture additional information and enhance the item records. In 2016, the notebooks were transferred from records into the care of the Wolbach Library, and soon after we partnered with Harvard Library Imaging Services to digitize the notebooks. As of March of this year, all of the notebooks have been scanned, and most are available online as fully browsable PDFs. Shortly after we began the digitization work, we also formed a partnership with Smithsonian Transcription Center, adding our scanned notebooks to the collection of material available for volunteers to transcribe on that platform. Over the last 3 years, nearly 180 PHaEDRA notebooks have been transcribed by volunteers, and we are getting ready to make those transcriptions available alongside the scanned notebooks. All right, for the next part, let me pass this on to Nico.
Thanks, Katie. So here, the next part or branch of PHaEDRA we call Star Notes, and we're using the Zooniverse platform, which is a crowdsourcing platform for doing all kinds of work with different kinds of collections. It started with the Galaxy Zoo, which was looking at images of galaxies and determining if they're irregular or dwarf or different types of galaxies. But now it's expanded to lots of other kinds of projects too. And we're using star notes in a slightly different way than we use the Smithsonian Transcription Center. On the Smithsonian one, we're asking volunteers to do full transcriptions of every page of every notebook, while on the Zooniverse, we're only asking them to find and transcribe what are called plate numbers. And Katie already mentioned that the Harvard computers would work with these glass plate photographs, and every glass plate would have a plate number to identify it. So if we can find and transcribe all of these plate numbers, that's going to allow us to make a critical link between the notebooks that these women used and the glass plates that they were actually working with. And there's another project called DASH to digitize all of the glass plates, which you'll hear about next month if you come back. And so far, we have over 5,000 volunteers, which is amazing. We just launched it earlier this year in January, and we've already completed the notebooks for Wilhelmina Fleming, Henrietta Swan Leavitt, Adelaide Ames, and Dorrit Hofflet. And there's still a lot of astronomers to go. We are mostly through Annie Jump Cannon's notebooks as well. And so volunteers have transcribed the plate numbers of 70,000 pages. We think that of the roughly 400,000 pages that make up all the notebooks in Project PHaEDRA, about 200,000 of those we suspect might have plate numbers. So given that 70,000 divided by 200,000, we think we're around a third done with the Star Notes project, meaning that it might go another 2 years, we think. Whoops. Okay, not sure what happened there. Let me see. All right, I'm not sure. So we started, Henrietta Swan Leavitt's notebooks were the first to be completed of all of the different astronomers. And we have 7 volunteers look at every page. The reason we do that is because we want to make sure that we have enough agreement between the different volunteers, because these are pretty, the pages are faint handwriting, often done in pencil. So they're often sort of hard to read. So what we're trying to do with Zooniverse is use many volunteers looking at each page to have some sort of confidence that the data we're getting is good and that we actually have identified the plate numbers on each page. And we do that using computer script. I had an image here, but if for some reason it didn't load, just showing that there can be some disagreement, but if we have a majority of people think that the plate number is this one, then if one person says, oh no, I actually thought it was this one, we can just automatically say, we're gonna go with the majority of people. And using these computer scripts, we've been pretty happy with the data that we've been getting back from Zooniverse. Over 88%. We have high agreement, meaning either they're finding all the same plate numbers, or they're all saying there are no plate numbers on this page. And only about 12% do we have either disagreement, which I'd categorized here as no match, or just something different. Usually it's a plate series that we don't recognize. Maybe it's not actually a plate series, that kind of thing. So those are things we'd have to look at again. But 88% is a pretty good rate for things that we feel highly confident in and could immediately start using to enhance our records. Okay, I'm going to turn it over to Sam.
Sorry, thank you. So the last part that I'm going to talk about is one of the most recent additions to PHaEDRA, which is the collections that we've added to the Learning Lab. So the Smithsonian Learning Lab is kind of a repository, I guess, for educational materials. Some folks from different Smithsonian affiliated museums and libraries, but a lot of teachers who aren't affiliated with the Smithsonian also put up their resources and such on this website. So we've started putting some collections on the Learning Lab. The collections that we have are specifically so far for middle schoolers and high schoolers. And a lot of these resources include images, videos, research, biographical information, and pages from the Project PHaEDRA notebooks. So a lot of times it'll be certain pages that might be of high importance or relate really strongly to the research and the work that these women were doing. So we started, we started launching these collections in September, so a couple of months ago. So far we have 5 collections up, and we're planning on adding another one this week on Cecilia Payne-Gaposchkin. So as you can see, we currently have collections on Annie Jump Cannon, Henrietta Swan Leavitt, Williamina Fleming, and other resources about astronomical images. So our goal with this branch of Project PHaEDRA is to connect the digitized notebooks and all of the work that has been done so far with the project with other resources that exist online. So whether that's books written by the computers or biographies written about them, videos and other educational materials, so that people can engage and learn from these resources. So we hope that these collections will provide really valuable resources for teachers and students to use, both as like primary source documents and also in other cases, such as videos and such, they can really make those connections between the materials. So I think that's it for me. I think now we'll be answering questions from the different kind of branches of PHaEDRA, and or just any kind of questions in general.